In this tutorial, we are going to solve a question from your tool sheet on intermolecular forces. Okay, so the question is saying a solution is prepared by mixing 5.81 gram of acetone. So being given the mass of acetone there, okay, the mass of acetone, the chemical formula of C3H6O. Okay, so the mass of acetone, we are being told is 5.81 grams. Okay, then we are being told the molar mass for this acetone. Okay, so the molar mass for acetone is 58.1 grams per mole. Okay, that's the molar mass. The mass and the molar mass for acetone will be given. And also, we are being told that 11.9 grams of chloroform. Okay, so we've also been given the mass for chloroform. Okay, it's CCl3. Okay, that's chloroform. The mass for chloroform, we are being told it's 7.9 grams, isn't it? And the molar mass for this chloroform will be given to be 119.4 grams per mole. Okay, then we are being told that 35 degrees Celsius, this solution has a total vapor pressure of 262. Okay, so now here we are being told that if we mix our chloroform and if we get the vapor pressure of our chloroform and the vapor pressure of our acetone, the entire solution, the entire mixer is giving us 262 as a total pressure there for the entire solution there, right? Okay, so this is the pressure that we are having if we mix our acetone and our chloroform. Okay, so now the question is this an ideal solution? So we need to confirm if this is an ideal solution. Okay, if not, we are being asked, we are being told, we are also being told that the vapor pressure of the pure acetone and the pure chloroform at 35 degrees Celsius, the same temperature. So what we are getting for the pure vapor pressures for acetone will be 345, and the pure vapor pressure for chloroform is 293 respectively there. Okay, so we are for the pure acetone, the vapor pressure will be 345, and then for the pure chloroform, the vapor pressure will be 293 there. Okay, so now the question is this an ideal solution if you are getting the total vapor pressure of the entire solution to be 262? So how are we going to confirm if the solution is ideal? Okay, so we are supposed to compare what we are getting here, the 262 that we've been given, and what we are going to get from the ideal vapor pressures that we've been given here. So we need to calculate the total pressure that we are going to get from the ideal vapor pressure that we've been given, which is 345 and 293. Okay, so once we calculate the total vapor pressure of the two pure mixtures there, then we are going to compare it with the vapor pressure that we have it. So how close these two vapor pressure? Okay, so is it lower than what we've been given, or is it higher than what we've been given? Then we are going to apply the Raoult's law to confirm if this is an ideal solution or not. Okay, so let's do that. So we are saying for us to know, we need to get the total vapor pressure of the pure acetone that we've been given and also the pure chloroform, isn't it? So, and we know that total pressure is going to be given by, okay, so we're going to get the mole fraction. Okay, so X is the mole fraction. Then we multiply it with the vapor pressure that you are getting, that will be given there. Okay, and then we are also going to add, since we are mixing, so we also do the same, get the mole fraction of the chloroform, okay, multiplied by the pressure of our chloroform that will be given, the pure chloroform there. So this, when we calculate the total pressure there, we're going to compare it with the one that we've been given. Then we are going to apply the ratio to confirm if the solution is an ideal solution or not. Okay, so let's do that. So now here we've been given the pressure there and the pressure there, but what we need is the mole fraction. Okay, so how do we get the mole fraction? We know that mole fraction X is given by, so we're going to get the number of moles of the acetone. So let's say, for example, we're having acetone there. So we get the number of moles of acetone if we are to calculate the mole fraction for acetone. So we get the number of moles for acetone divided by the total number of moles of the entire solution that we are having, right? So we're going to get the number of moles of acetone divided by the number of moles of acetone plus the number of moles of chloroform. So we get the total number of moles that you are going to get. So that tells us that we need to know the number of moles for our acetone and also the number of moles for chloroform. Then those values are going to help us find the mole fraction, isn't it? So let's do that. Let's find the number of moles for, okay, so here I'm going to find the number of moles for acetone, which is C3 H6O. Okay, so we know that number of moles is going to be given by mass divided by molar mass, isn't it? Okay, so here we are having the mass. We've been told that the mass of acetone is 5.81 gram, okay, per, okay, so that's a mass, right? And then divided by the molar mass, which is 58.1 gram per mole, right? Okay, so that the moles and the moles will go there. Then if we divide our 5.81 by 58.1, we are going to get the number of moles to be equal to, okay, so there I'm getting my number of moles to be equal to 0.1. Okay, so I end there. So I have 0.1 moles. Okay, then now I also need to calculate the number of moles for my chloroform there. So I do the same. So number of moles for chloroform, okay, which is HCl3 will be equal to, we apply the same formula, mass divided by molar mass. Okay, so the mass that we've been given there is 11.9 grams. Okay, so 11.9 grams, okay, divided by the molar mass for our chloroform, which is 119.4 grams per mole, right? Okay, so there we can divide. So the mass, the grams and the grams will go, means that you are going to remain with moles as a final answer. So there, when I divide to three significant figures, I'm going to get 0.0997 moles. Okay, but when calculating, just make sure you get the entire number that you're getting on the calculator. For the sake of time, I'm just going to be using three significant figures there. Okay, so that's what I'm having there. Okay, I see my number of moles for chloroform. So I have the number of moles for chloroform and the number of moles for acetone, isn't it? So that those values will help me to find the number of the mole fraction for chloroform as well as the mole fraction for acetone. So let's start with the mole fraction for acetone. Okay, so for the mole fraction of acetone, which is C3H6O, so that will be equal to, so I'm going to get the number of moles for acetone, okay, the number of moles for C3H6O divided by the number of moles for C3H6O plus the number of moles for HCCl3 for chloroform there. Okay, so that will mean that this will be equal to the number of moles for acetone will be 0.1, okay, divided by the number of moles for acetone, which is 0.1, plus the number of moles of chloroform there, which is 0.90997, isn't it? Okay, so there I can calculate there, right? Okay, so let's do that. Okay, so we get this this will be equal to, so we're having 0.1 on top divided by, so now we divide we add 0.1 plus 0.0997, okay, so 0.0997. Okay, so we're going to get 0.1997 there. So this will be equal to, so when we divide there, I'm getting my final answer to be, so get three significant figures, that is 0.501, right? So this is my mole fraction for acetone. So I can put the mole fraction for acetone there, which is 0.501 multiplied by the vapor pressure for acetone, the pure acetone will be given there, which is 345 there, right? Okay, then plus, now we do the same here. We have to calculate the mole fraction for chloroform as well. So we apply the same concept, okay? So we are saying mole fraction for chloroform, which is HCCl3, okay? It's given by the number of moles for chloroform divided by the number of moles for chloroform plus the number of moles for acetone there, right? Oh, like that, okay? So the number of moles for chloroform, we are saying it's 0.00 or 0.997, isn't it? Those are the number of moles for uh, our chloroform divided by the number of moles for chloroform, which is 0.0997 plus the number of moles for acetone, which are 0.1 there. Okay, so there we're going to have this will be equal to, so on top we're having 0.0997 divided by, so when add 0.0997 plus 0.1, so we are going to get our answer to be 0.197 as well, isn't it? So this will be equal to, so when we divide there, my final answer, three significant figures, I'm getting 0.499 there. Okay, so I have my mole fraction there, so I can put it there on the where I'm having X, the mole fraction for acetone. So this is the mole fraction for, this is the mole fraction for chloroform, okay? Also, this is the mole fraction for acetone there. So just make sure you indicate so that you don't forget, okay? So I'm getting the mole fraction for chloroform to be 0.499 multiplied by the partial pressure for the vapor pressure, sorry, for our chloroform, which we've been told it's 293 there, right? So these are in total, so meaning our final answer is going to be in total as well. Okay, so let's do that. So here I multiply 0.501 times 345, okay, then I add 0.499 times 293 there, okay, so my final answer is going to be, so in three significant figures, I'm having 392, okay, so that's my final answer there. So this is what we are this is what we get from the this is what we get from the pure vapor pressures of acetone, isn't it? So the total vapor pressure there, we're getting 319, isn't it? And we're being told that for the solution, what we are getting after mixing, we are getting 260. Okay, so you notice that if we compare 260, okay, which we are getting in the mixer, okay, so this is what we observe that we are getting, and what we are calculating, you notice that what we are what we expect is lesser than what we are getting, isn't it? So what we are getting is more than what we expect in that case, okay? So if we are to apply the Rauch rule, so it means that we are getting a negative deviation, okay? So in this case, we are saying what we are observing, the observed vapor pressure that we are getting there is 260, okay? And then the calculated, so this is the observed, the one that we get from the mixer or the two, okay? So we are getting 262 there. And then what we are calculating from the pure mixers there, or the two, Okay, so what we are calculating is 319. So you notice that what we are observing is lesser than what we are calculating there. Okay, so this is greater than that one. So if we apply the Rauch rule, it means that we are getting a negative deviation. Okay, so we get a negative deviation. So that means that uh, our solution is not an ideal solution. So that's the final answer there. So this is not an ideal solution. Okay, so that's what we have here. Okay, so now if you want to access the full video solution on this tutorial sheet, you can access them on the website. So let me just show you how you can access them. So this is the entire tutorial sheet on intermolecular forces. So you can see this is the whole tutorial sheet. Okay, so now um, if you want to access the full video solutions, so you can go on our website. So if you are using an Android phone, you can download our app on Play Store. Just search discretelearninginstitute.com. So you are going to uh, 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 follow the course that you are subscribing for. Okay, so once you subscribe for that course, you should be able to access the folders that are available there. So for example, if you subscribe for chemistry, so you can see this is the folder for chemistry, then you should be able to go in this folder written tutorial sheet and assessment. Okay, so to ask you the university, so you need to pick your university. So let me just open. So I go in that folder written tutorial sheets and assessment. So it will bring this university here. So you can pick your university, let's say UNAS. So it will take you to these folders here. So you pick your semester. So you go in second semester there. Okay. So we go in second semester. Let me just wait for it to load. Yeah, so you choose your intake. So you go to 2026 January intake there. Okay. So then you open. Okay. Yeah, so you are going to see the tutorial sheet that you are having. So this is tutorial sheet 2. So you go in that folder written tutorial sheet 2 intermolecular forces. Then you find the full video solution for this tutorial sheet here. Okay. So this one here. Okay. So that's what we have for this video. Thank you so much.